Question number 10, relative decrease in the vapor pressure of an aqueous solution containing 2 moles of a coordination compound, which is of the Cu NH3 3 times Cl bracket Cl, right? In 3 moles of H2O is half. When the given solution reacts with excess of AgNO3, the solution, the number of moles of AgCl produced is option A given is 1 mole of AgCl, B 0.25 moles of AgCl, C 2 moles of AgCl, and D 0.40 mole of AgCl. All right, now in this particular consideration, let's take into concept of the mole fractions. So when we are speaking about the mole fractions over here, what we know is that mole fraction of a compound, the mole fraction of a compound, let's take into consideration of Van Hoff's factor divided by n, the whole thing divided by Van Hoff's factor into n plus of n. So this will give us a value of I into 2 divided by I 2 plus 3. Okay, so it is nothing more than the number of moles produced upon the ionization of this particular compound, right? So it splits out into 2. So therefore, we have I2, right? N is the 3 moles. So therefore, now, relative lowering of vapor pressure. So relative lowering of vapor pressure is equal to, so delta P over P. Now what they have said is it is equal to half. Half is nothing more than 0.5, right? So, but according to RLVP, okay, now the previously we had seen that delta P over P is equal to N2 over N1 plus N2. That is nothing more than the mole fraction, right? But the mole fraction is equal to, right now what we have taken is a new equation, 1I into N divided by I into N plus of N, right? So therefore, we can say that 0.5 should be equal to I2 divided by I2 plus of 3, right? So therefore, when we consider this, I2, when we multiply this particular point over here with 0.5, we are going to end up having I into 2 plus, okay, I into 2 plus, let's take it as over here, let's take this entire term as just as 1 over 2, so that it will be much more easier for us. So because we can just shift this particular thing over here, I into I2 plus 3 is equal to, now 2 into I into 4. So this is what we can get over here, right? So let's keep this 1 point over here into consideration. Okay, now, therefore, what we have is I, when we solve it, okay, so when we solve, what we have here is I into 2 plus 3 is equal to I4. Now, let's shift the i's to one side. So therefore, it is going to become as I2, right? Because I2 goes on the other side, that is on the right side, it becomes as a minus of I2. So I4 minus I2 becomes as I2 again. So therefore, I is equal to 3 by 2, and that is going to give me a value of 1.5. Right? So let's keep this point aside now, and let's take this along with the degree of dissociation. So what we know is that I is equal to, we have an expression that is 1 plus of 1 minus of n into alpha. Now I value we have is 1.5 is equal to 1 plus 1 minus of n. Okay, now n I do not know, and alpha, okay, alpha, that is the relative, okay, so alpha is the degree of dissociation, so that is given as the half. Okay, so therefore the number of moles produced is equal to Therefore, the number of moles of Cl minus is equal to, so what we have is 1.5. Okay, so therefore when we solve this, it's going to be as is equal to 2 into 1 over 2. Okay, and that is going to be as 1 mole. Okay, therefore we can say that N is equal to 1 mole is going to be produced. That is 1 mole of AgCl is going to be precipitated, right? So therefore answer is the option A, 1 mole of AgCl.